Pedometrics II Brazil, November 2021. Hello, everyone. I am Dr. Jean Novaes. I am an agronomist, specialist in geotechnologies, PhD and Master in Agronomy, within soil, water and environmental quality concentration field from Faculty of Agronomy and Veterinary Medicine in the University of Brasilia, Brazil. My work abstract title is Soil Spectral Behavior in a Tropical Toposequence on Metasedimentary Rocks. Introduction. This work is part of the author's doctoral thesis, and it was developed in a micro-watershed in the Agua Limpa Experimental Farm, FAL, between 2019 and 2020. It was performed at the Laboratory of Geoprocessing and Pedomorphogeology, GeoPed, which is linked to the Faculty of Agronomy and Veterinary Medicine. Factors such as climate, organisms, relief, rocky matrix, age, and soil arrangement in space are responsible for pedogenesis. These factors provide characteristics and attributes that allow the distinction between soils, for instance, texture, natural fertility, structure, water-holding capacity. Such characteristics can be determined by morphological in the field, physical and chemical laboratory analysis, including remote sensing techniques such as reflectance spectroscopy and optical range. The spectral behavior reveals several soil compounds and characteristics, such as mineralogy, texture, moisture, and organic matter. My objective was to classify the soils and qualitatively evaluate them regarding the influence of pedological attributes on the spectral behavior of soils in a tropical toposequence formed on metasedimentary rocks, Paranoá group for soil mapping. Methodology. Fieldworks followed recommendations from soil survey staff, 2014, in a toposequence formed by 5 soil profiles. Thus, the samples were collected at depth 0 to 20 cm for the surface and 10 to 100 cm for the subsurface layer. These samples were air-dried, mashed, and sieved, particles lower than 2 mm. Then, they were submitted to physical, texture, and chemical, assortment complex, analyses in the laboratory. With results, the profiles were classified according to World Reference Bases for Soil Resources, 2014. Surface soil samples also were analyzed by reflectance spectroscopy from visible and shortwave infrared range, from 0.35 m to 2.5 micrometer, using the Field Spec Pro hyperspectral sensor, which were morphologically interpreted according to main absorption features, identifying some attributes that characterize the soils, such as mineralogy, organic matter, and texture. Finally, the soils were interrelated according to position in the landscape, tracing a profile of soil evolution based on the silt/clay ratio, which the pedomorphogeological relationships conditions were considered as factors that alter soil spectral behavior. Results and discussion. Typically, the soil presented texture ranging from very clayey to loam sandy. Base saturation below 50% characterized district soils. Tropical soils tend to present low natural fertility, acidic character, and high iron oxides and aluminum content. The soil classes were determined as P1 clayic, district, rhotic Ferralsol, P2 clayic, district, rhotic Ferralsol, P3 clayic, petroplinthic, district, Haplic Ferralsol, P4 clayic, district Haplic Gleysol, P5 loam sandy Hemic Haplic Histosol. As long as the altitude decreases, the weathering action also decreases in a toposequence because of the insufficient local drainage, which favors the formation of hydromorphic soils. Profiles in the upper of toposequence exhibited a high degree of evolution than the bottom. It was possible to note the occurrence of specific processes of soil formation such as fertilization in P1, P2, and P3, while in P4 and P5 occurred simultaneously plinthisation and oxidation caused by reductions in the internal water flow. Such changes gradually influence the general spectra behavior. However, more detailed studies in the domain of time and space are necessary to explain the pedogenetic relationship that confers the distinctive properties of soils within spectral reflectance. The morphological interpretation of reflectance spectra showed the typical features of primary and secondary minerals, as well as oxides' influence and obliterating action of organic matter throughout the spectra. Different features were observed in the toposequence profiles. These features are highlighted in bidirectional graphs. Basically, they exhibited iron oxides such as goethite in 0.48 and 0.95 micrometers, and hematite in 0.53 and 0.85 micrometers, 1-for-1 minerals as kaolinite in 1.4 and 2.205 micrometers, gibbsite 2.265 micrometers, and traces of 2-for-1 clay mineral and water adsorbed on the particle surface in 1.405 and 1.9 micrometers, typical from tropical soils highly weathered. Conclusions. Features of primary and secondary minerals, iron oxides, and organic matter were observed in the spectral curves in the toposequence. They were related to chemical physical analyses, reinforcing their utility for soil classification. A quantitative approach can support the potential of spectral information for tropical soil mapping and in other parts of the world. Thanks for your attention. See you.